In this video, you're going to learn about limits, and we're going to be talking about left-hand limits, right-hand limits, and just limits in general. And we're going to be doing this from the perspective of looking at a graph. So let's go into the three examples that we're going to go through together. This first one, f of x equals x squared minus 3, you know it's a parabola that's been shifted down 3 units. But what we're going to do now is talk about the notation. So the limit as x approaches 1, this minus sign here means from the negative or the left side. So what you're going to do is you're going to follow the graph, okay, and you're going to approach this x value of 1. And as you stay on this graph and you're approaching 1 from the left, what y value are you getting closer and closer to? Well, you can see when x is 1, we're down here at negative 2. So as you approach 1 from the left, f of x, which again is the y value, you're getting closer and closer to a y value of negative 2. Now the next one, the limit as x approaches 1 from the positive or the right side, okay, so you're going from this direction, what y value are you getting closer to as x approaches 1? So we're on the graph, kind of like a road, you're approaching this x value of 1, and as you get closer and closer to 1 from the right side, what y value are you getting closer to? Again, looks like negative 2. Now if the left-hand limit and the right-hand limit are the same, you're approaching the same y value from the left and the right, then the limit as x approaches just 1, without that minus or plus sign here, basically from both sides, it's approaching a y value of negative 2. Now if you're approaching two different y values like this, then we would say that the limit at 1 does not exist. But in this case, since these match, this is our limit. Sometimes what you're going to have is this sort of a situation where at that particular point, it might not even exist, but the limit you're getting like infinitesimally close, meaning like you're getting closer and closer and closer from the left. You don't actually get there, but you're approaching a particular y value. Maybe you're approaching it from the right, closer and closer and closer. You don't actually get there, but you're like really, really close. If you're approaching the same y value from both sides, that is going to be what your limit is, whatever that y value is. Let's look at another example. Okay, for our second example, we're going to be looking at f of x equals the absolute value of x minus 3 just divided by x minus 3. So if we graph that, and you can do this on your graphing calculator, you can see that we're getting this type of a graph here. Now let's look at the limit. So the limit as x approaches 3 from the left, see that minus sign means from the left. So here's 3 right here. As I'm approaching from the left, what y value am I getting closer and closer to? Well, it looks like I'm getting closer and closer to a y value of negative 1. Now the limit as x approaches 3 from the positive or the right side, so here's 3, as I approach 3 from the right, looks like I'm getting closer to a y value of positive 1, okay? And then the limit as x approaches 3 from both the left and the right sides, they're not approaching the same y value. See how these are different, negative 1 and positive 1? So at 1, the limit actually does not exist. This is oftentimes referred to as a jump discontinuity. You're going along like this, and you jump up to here. A removable discontinuity is where you just have one missing point. Like if I filled this with one pixel or one dot, it would then become continuous. There'd be no break in the graph. But this is a jump discontinuity. Now, a couple bonus questions here. For letter D, the limit as x approaches 0. Now, x equals 0 is right here. As I approach 0 from the left and the right, what y value am I getting closer to? Looks like negative 1, okay? Notice there's not a left-hand limit or right-hand limit. It's just saying the limit as x approaches 0. So that's from both sides. As you get closer to x equals 0, what y value are you getting closer to? Negative 1. Now, again, remember limits. You get really close. You don't actually have to reach 0. But you want to see what you're approaching from both sides. Okay, now for letter E, f of 3. Now this is talking about our function notation. This is our x value of 3. If I put 3 into my equation here, what's my y value? Well, you can see there really is not a y value. See, limits, we get really close, right? F of 3, we're talking exactly at x equals 3. So if x equals 3, if this was a closed circle, I would say, oh, the y value is 1. Or if this was closed, oh, the y value is negative 1. But right at x equals 3, there is not a corresponding y value. So this does not exist. And lastly, what's f of 4? 1, 2, 3, 4, that's right here. We go up to the graph. Remember, f of x is like saying, what's the y value? You can see right here, we're at a y value of 1. Let's take a look at one more example. Okay, for example number 3 now, we have f of x equals 1 over x minus 3. And if you graph it, you'll see you get a graph something like this. And if we take a look at the limit as x approaches 3 from the left, So here's x equals 3. We're approaching from the left. Now you want to stay on the graph. As you're getting closer and closer to an x value of 3, see how this graph takes a nosedive? It goes down towards negative infinity. Whoops, this one here, negative infinity. Now for this one, the limit as x approaches 3 from the positive or the right side, here's x equals 3. We're approaching from the right. We want to stay on the graph. You can see it's going up and up towards positive infinity. So if we just look at the limit as x approaches 3, from both sides, as you approach from the left, it's going down. As you approach from the right, it's going up. They're not approaching the same y value. Okay, this means that the limit at 3 here actually does not exist. This is sometimes referred to as an infinite discontinuity. See, it's like infinity here. You have this asymptote. And then lastly, the limit as x approaches 2 of f of x. So here's x is 2. Now it doesn't state whether it's from the left or the right. It just says x approaches 2. So from both sides, as we approach from the left and the right, what y value are we getting closer and closer to? We don't have to actually reach it, but from the left and the right, we're getting closer to a y value of -1. So that's our limit. Great job if you're able to follow these examples in this video. If you want more practice, I have another video that I did talking about limits. Follow me over to that video right there, and we'll get some more practice. I'll see you there.